The real test of a student is not how well he knows his lessons, but how well he can apply them to real-world problems. For the final lesson in this series, look at how matrices can be applied to one such problem. To solve it, we first need to extract equations from the given conditions. Once we have it, we can apply the matrix inversion method as asked. The only new thing here for you is the making of equations from word problems. You have already learned the rest. To start the solution, I'll draw a rectangle of some length and width on the screen. According to the question, the length is 6 centimeters less than 3 times its width. The second condition is related to the rectangle's perimeter, which is defined as the total length around a closed figure. Follow me as I highlighted for you. Right, up, left, down. For rectangles, the perimeter is given as 2 times the sum of the length and the width. The question says that the perimeter is equal to 140. Now, if I label the width as x and y as the length, then equation 1 becomes this, which can be rearranged like this. As for the second equation, after replacing the length with y and the width with x, it becomes this. If you take this 2 over there, then the equation becomes this or this. Now, we have both the equations in standard form, x first, then y, and constants on this side. Now, the question asks you to find the dimensions of the rectangle, that is, the width and the length, and they are represented by x and y here. Therefore, what you need to do is to find the values of x and y. Let's start. We have to solve these equations with the matrix inversion method. We know the formula is x equal to the inverse of A by B, where x is the matrix of variables, A is the matrix of coefficients, and B is the matrix of constants. For matrix A, we place the coefficients of x in the first column and those of y in the second column. That is 1 and 3 here, while 1 and negative 1 here. X contains the variables x and y, while B has constants 70 and 6. Now, to find the inverse of A, we need the determinant of A first. We have 1 by negative 1 minus 3 by 1. That equals to negative 1 minus 3, which is negative 4. Negative 4 is a non-zero number. Thus, the inverse exists. So, we continue with the solution. For the adjoint, swipe these two, change the signs of these, and then populate the formula of the inverse. Again, I'm not taking this negative 4 inside the brackets to avoid complications. Now, finding A inverse into B, the resultant order will be 2 by 1. So, here is that matrix. Writing this scalar value outside as it is and multiplying the first row with the first and only column to get the 1, 1 position. Now, I am multiplying the second row with this column and the result comes at 2, 1. By solving, we get negative 76 and negative 204. Now, divide both the entries by negative 4 and we get 19 and 51 with x and y on the other side. Both the matrices are equal. So, by comparing, x or the width is equal to 19 centimeters and y, which is the length, is equal to 51 centimeters. The question ends here, but if you want to verify your results, you can put the values of x and y in any of the equations above. Take y plus x is equal to 70 and y is equal to 3x minus 6. Put x and y here and you can see 70 equals 70. For the second equation, we get 51 is equal to 3 by 19 minus 6, which is 51. This way, the equations are verified. Thus, the results are correct. That's it for our series on matrices. I hope you enjoyed learning about them as much as I enjoyed teaching you about them. Hope to see you back here soon.